Welcome to Dr. Yeap Ban Har's Problem Box. In today's lesson, we are going to solve a problem. Let's see what problem we have for today. And today, we have this problem. We are given a figure. All the lines are straight lines. The problem is this. If we know the values of these three angles, this one, and that one, is it possible to find the sum of these two angles? This one and that one. That's our problem for today. Can you try to solve the problem in, hopefully, two different ways? Why don't you give it a go? Let's try. Have you managed to solve the problem? How far are you in trying to solve the problem? Which is, what's the sum of this angle and that angle? They are not necessarily equal. I'm just putting crosses to show you where the two angles are. And we are given the values of these angles, whatever they are. They are not necessarily equal. I'm just using a mark to show you where those angles are. Spiky has an idea. His idea is to make a triangle by drawing this line. I'm not sure how his idea might work out, but that's Spiky's idea. Spiky says that we know about the sum of interior angles in a triangle. We know the sum of those three angles, 180 degrees. So Spiky thinks that we can make use of that. We also know about this angle compared to that angle. When we have two straight lines crossing, we know that this angle and that angle, they are equal. And Spiky thinks that we can make use of those to figure out the total of those two angles. Early, she has a different idea. She thinks that we can draw this straight line to create a triangle. And because we know about angles on a straight line, those two angles add up to 180 degrees, we can try to make use of that and maybe other information to solve that problem. Why don't you continue with those ideas and see whether or not they work? What's the answer? Let's try Spiky's idea. Spiky suggests we add this line. Does it help? We know about angles like this being equal. That's right. So this and that, they must be equal. We also know about angles in a triangle. They always add up to 180 degrees. So we know that those two, together with this, they add up to 180 degrees. We also know that this one and those two also add up to 180 degrees. What does that mean? If these two are equal, and those three, each of them is equal to 180 degrees, is that right? The total of these two must therefore be equal to the total of those two. So if we can find out what is the total of these two, we have found out what is the total of those two. But how can we find out the total of these two? Remember, we know the values of these angles. We can give them numerical values. 60 degrees, 30 degrees, 20 degrees. For example, for those values, are you able to find out the sum of those two angles? They must be equal to this to add together. You are right. This, that, and that, they add up to 180 degrees. And the known values already add up to 110 degrees. That means these two must add up to 70 degrees. If these two add up to 70 degrees, those two must also be 70 degrees. That's Spikey's method. What about Curly's method? Curly's idea is to extend this line. Does it help? So we need to know the total of these two. And we are given the values of these three. In fact, for us, we have given that value 60 degrees, that one 30 degrees, and this one 20 degrees. Can we find the sum of these two angles using Curly's idea? Remember, we do know about this angle and that angle adding up to 180 degrees. Can you see triangles? I see that triangle. For that triangle, if we know these two values, I think we know that value. That is right. This value got to be 100 degrees. They must add up to 180 degrees. So if this is 100 degrees, so what? That's right, we do know that will be 80 degrees because that's a straight line. And if we know that is 80 degrees, this is 30 degrees, that must be 70 degrees. But is all that useful? We know that this angle and that angle, they add up to 180 degrees. We also know that those two angles, together with this angle, those three, they also add up to 180 degrees. What does that mean? This and that, total 180. These two and that, also total 180 degrees. That is right. These two must be equal to that. So now we have solved the problem using Curly's method. If you find today's problem easy, why don't you be the teacher and create a few problems in geometry like the one we just solved? Those problems must be solvable using only 4 ideas. The idea that the sum of angles in a triangle is 180 degrees. The idea that those two angles on a straight line, adds up to 180 degrees. Thirdly, angles at a point, they add up to 360 degrees, and when two lines cross, those angles are equal. Can you come up with 3 to 5 different problems in geometry that are solvable using only the knowledge of those 4 things? Challenge yourself if you find today's problem easy. See you next time in another problem box.
I can't forget the day we met. Your eyes so blue, me present